Parallax and measuring distance to stars.
Have you ever traveled down a road in a car and looked at the mountains or hills in the distance? If you have, you've probably noticed that while nearby trees quickly fly past the window, the mountains move much slower, and in the far distance, the moon and the stars don't seem to move at all. As you move, objects closer to you, such as the trees, seems to shift position relative to more distant objects, like the
Okay, trees are close, mountains are mid-range, stars in the background. You have 3 levels of distance, and they have equivalent speed of movement as far as your eye is concerned.
mountains. This effect is called parallax. The size of this shift depends on the distance you travel along the road and how far away the trees are. The closer they are to the road, the bigger the shift. The same thing happens as the Earth moves around the Sun. Over the course of a year, some stars appear to move a very small amount relative to other stars. Like the trees along the side of the road, these stars are just closer than those that don't seem to move. Actually, all stars are moving through space, but much more slowly than parallax, so we don't notice. Now, if we measure how much a star moves when the Earth does one complete trip around the Sun, we can use this to work out this angle, called the parallax angle.
And there you go, the parallax angle. It is the angle formed from a complete circular orbit around the sun. Starting point, the midpoint, back to the starting point. Now, if you project those lines out to the object in the sky from both positions, they will intersect. That's basic geometry. There's no such thing as infinity, really. All right? So now you're going to have an angle, which is the parallax angle, and it'll talk more about that.
If we observe a star when the Earth is at one spot in its orbit, and then wait 6 months for the Earth to move around the Sun to the opposite point along its orbit and observe the star again, we can measure the parallax angle.
And in geometry, if you remember, opposite angles are equal. This angle here, from December to June, is exactly the same as this angle here. Just trying to prove the mathematical point, because now you'll be able to make, using formulas, some computations for that. Not you yourself, but understanding the process of how it's done. Basic geometry. Little trick, I think.
Since we already know the distance from the Earth to the Sun, we can now use this parallax angle and some trigonometry to work out exactly how far away the star is. This is really useful because it allows us to calculate the distance to nearby stars very accurately. This can then be used to check the distance measured by different methods to even more distant objects out in space.
Now, you didn't have to worry about the mathematics here. All right, that was not an issue. But if you want to come back to it very briefly, to look at the formula, these are called astral units. If you see that term in the text, then you will. That simply means a unit of measurement as far as the entire universe is concerned. It's a new measurement, much greater than a mile, more like light years and so on. But it is a unit of measurement. Okay? Don't worry about the formula. But if you see something like this, and the question is, what does this do? You'll know it means compute parallax. Other than that, don't worry about the formula.